So hello everyone, this is lecture 31 for the mathematical physics. In the last lecture we started actually the complex analysis, and we completed the introduction of some terms. Inside we will use the terms. In today's lecture we will start with polar form representation of complex number in a complex plane. Okay, just like you understood that what is the meaning of polar form. It means representation of some coordinates in the form of r and theta. Okay, so let's say this is complex plane and we have this complex number whose coordinates are x plus iota y. Now this length is called the mod z and this length is r and this angle is theta. So this x will be r cos theta and this y will be r sin theta. So we can represent this z in the form of this. X is r cos theta, r will be taken common, and it will be r cos theta plus I sin theta, where r is called the absolute value or modulus of z and r is mod z, and theta is called the argument of z and we write it as argz, and this is nothing but y over x. That's how you can find the tan theta. So theta will be tan inverse y over z, y over x. So this will be your argument. So these were the some introductory terms for the polar form. Now let's say we have, so what is this mod z? This mod z is distance of point z from origin O. Okay, now let's see, we have 2 points z1 and z2 in the complex plane. Now we need to find this distance. So this will be from z2 to z1, it will be z1 minus z2 ka mod. Okay, so z1 minus z2 is the distance of point z1 from z2. So this will give you distance between z2 and z1. Geometrically, theta is the directed angle from positive x-axis to OP. So what will be theta? Theta will always be measured from this x-axis towards this point. Means when you take it anti-clockwise, it will be taken positive. When you take it clockwise, it will take a negative. We will study more about this. This it was the introduction. So theta is a directed angle from x-axis to OP. OP is this line. So theta is measured in radians and is taken positive in anti-clockwise direction. For z equal to 0, theta is not defined. So for z equal to 0, theta will not be defined. But for z is not equal to 0, theta is determined up to integer multiples of 2 pi. So what is the meaning of this integer multiple of 2 pi? Means if we have some complex number and we find this theta, now we can add 2 pi, it will come again to this point, then again 4 pi, it will come to again this point. So that's how you represent, means it should be multiple of 2 pi so that it will always remain the same. Okay, so theta should be always a integer multiple of 2 pi. Hope you get this point, that why we are taking the integer multiple of 2 pi. Now let's see some more things. Let's study about the principal value of theta. So as I already told you, if theta is multiple of 2 pi, then we have infinite number of values possible for theta. Let's say you have here pi by 4, then it will be pi plus 2 by 2 pi, pi by 4 plus 4 pi, pi by 4 plus 6 pi. That's how you can get infinite number of values for theta. But there is some values which are called the principal values that are fixed. So what are principal values? So principal value of theta, the value of theta that lies in interval minus pi to pi. It should be, theta should be greater than minus pi and less than equal to pi. So remember this equal to sign here, not equal to here. So when theta is between this minus pi, greater than minus pi and less than equal to pi, then theta is called the principal value of z and is represented by capital ARG z. Okay. So let's say we have this plane. Let me define you. So when you measure this angle like this, so you will go up to pi only. After that it will be out of this range. So how you can measure this lower side angle? So you have to go this way in the minus direction clockwise to measure this angle. It will go up to minus pi. So 0 to pi or 0 to minus pi, and that's how the limit of theta will be minus pi to pi. Okay, and for this line, theta will be pi, not minus pi, because it should be greater than minus pi and equal to pi. So when angle lies between this range, means either this side or this side, and that angle is called the principal value of that z. So we will see examples. It will be clear to you more then. So argument of z, a general argument, will be always sum of principal value plus 2 and pi. Okay. So here n can be 0, 1, 2, 3, 4. For n equal to 0, you will get again the principal value. This will be 0. And for 1, you will add 2 pi and 2 pi. That's how to multiple of 2 pi. So let's see some examples. When our z is 1 plus 0 iota, so it will lie somewhere here. So y over x, y is 0, x is 1, so we will get 0. So theta will be 0. So this is our principal value for this, because 0 lies in this range. Now let's see if our complex number is 0 plus iota. So it will be 1 upon, means it will be infinity. So for tan theta, infinity at pi by 2. So that's why we are getting theta equal to pi by 2. This is pi actually. Okay, so this will be our argument, principal value of argument. Okay, principal argument, theta pi by 2 and z equal to iota. Now let's see, we have this point here, minus 1 plus 0 iota. So this should be pi, because minus pi can't exist in this principal value. This should be greater than minus pi and less than equal to pi. So this is pi. So principal value for this will be pi. See here once, let me tell you. Now here you can take this value also. This will be 3 pi by 4. Now see, this 3 pi by 4 doesn't lie in this range. That's why we don't write this argument value as 3 pi by 4. So only this value or this value can lie inside that range. So that's how you define the principal values. Let's say now we have point here. So below this axis the argument is always negative, and above this axis the argument is always positive, and just you need to measure that theta. So now for this, theta will be pi by 2, so argument will be minus pi by 2. Now let's say we have this as our complex number 1 plus iota, so it will lie somewhere here. So we need to measure this theta. It will be y over x, so it will give you pi by 4, so argument will be pi by 4. Now for this, when it will lie here, again just take the absolute value of y by x, it will give you pi by 4. So now this is this pi by 4, an angle is measured like this. So pi minus pi by 4 will give you 3 pi by 4. So this will be 3 pi by 4, argument for this. Now for this is again minus 1 minus iota for this. So absolute value will give you pi by 4 theta, but you need to measure this line. So this will be minus 3 pi by 4. Now for this, because all the downside will come in the negative terms, so just take the principal value and put the minus sign before it as prefix. So this will be our 1 plus minus iota, so it will give you, this theta will be pi by 4, and because it is in this side, so it will be minus pi by 4 argument. So that's how you can find the values. Just calculate the tan inverse y over x absolute value, and then see where it is that complex number lying, in which quadrant, then put the sign accordingly. And if it is lying here, then it will take pi minus. It is lying here, then take pi minus and plus, and pi minus minus, and here is just minus and just plus theta. So that's how you will measure the principal values. So try some examples and it will be clear to you. Like it is given z equal to 3 plus 4 iota. So 3 and 4 both positive, so they will lie in this quadrant, and theta will be tan inverse y over x. So this will be your argument value. So hope this is clear to you. If you are still having doubt, put in the comment section. Now let's see the triangular inequality. So you know guys about this, that if there is any triangle, then sum of any two sides will always greater than the third side. So in complex number, how we can define this? So this z1 plus z2 will always less than equal to, means the mod of z1 plus z2 will always less than equal to the sum of individual modes of z1 plus z2. Okay, and difference of z1 minus z2, the mode of difference will always greater than the individual difference of z1 z2. So remember this is a very important property. We can prove this also. Means if this is our triangle, Then from this first property, we know this mod z1 plus z2 less than equal to mod z1 plus z2. So let's say mod z1 equal to this, means plus minus z2, take the plus minus z2. Now we can just use this first property, this one, this z1 plus z2 mods will be less than equal to this individual mods. So this is equal to this, and this will less than what, the individual mods z1 minus z2 and z2. Now take this to this side, we will get z1 minus z2 less than equal to mod z1 minus z2. So that's how you can prove this second property using 1, and 1 can be proved using second. So remember these results, very important. Now let's see multiplication and division in the polar form. So this is very interesting topic. Let's say we have one complex number as z1. We can write it in this form, polar form, r1 cos theta 1 plus I sin theta 1. And for 2 it will be r2 cos theta 2 plus I sin theta 2. This theta 2 is argument for z2 and theta 1 is argument for z1. And r1 is mod of z1, r2 is mod of z2. Now take the simple product z1 z2. It will give you r1 r2, then multiply these terms inside. So you will get cos theta 1 cos theta 2 plus I sin theta 2 cos theta 1, and these all terms. Now separate the real terms and the imaginary terms. You will see that you will get cos theta 1 cos theta 2 minus sin theta 1 sin theta 2. So this is something like cos x cos y minus sin x sin y. So this is nothing but cos x plus y. So we write it like this. Then take iota common, and this will be sin theta 2 cos theta 1 sin theta 1 cos theta 2. So it is like sin x cos y plus cos x sin y. So it will be sin x plus y. So we get this. So z1 z2 equal to r1 r2. This is equal to sin. So r1 r2 is this. Now compare this with a single equation, means for z equal to r cos theta plus I sin theta. So this will be our product of z1 z2, and argument will be of z1 z2 will be theta 1 plus theta 2. So that's how you can find its product will be r1 r2, that is mod of z1 mod of z2, and argument of z1 z2, the product of two complex number, argument of that will be sum of argument of 1 and argument of 2. See, you can compare this equation with that, cos theta plus I sin theta. So theta will be theta 1 plus theta 2, and r will be r1 r2. So argument of z1 z2 will be sum of argument of individuals, and then again up to multiples of 2 pi, you can add them. Now let's see the divide rule. So z, let's say z equal to z1 by z2 is a complex number such that if you here find that, then z1 should be equal to z into z2. Now if you take the mod, then z1 mod will be z z2. So let's say it's like a product of these two numbers. Z1 is product of z z2. So argument of z1 will be argument of z plus argument of z2. Then argument of z can be find it, that will be z1 minus z2, using this result. This was the sum for the product. So for this product, argument of z1 will be sum of arguments of z and z2. So here you can find that argument of z will be z1 minus z2. And for dividing, z1 equal to mod z z2. From here mod z will be mod z1 mod z2. So if z is this dividing, then the mod of z means, if you compare this with that, z equal to r cos theta plus I sin theta. So for that r, the mod of z will be mod of z1 divided by z2. It means it's a simple divide, r1 over r2 for the mod, and inside for argument we already find it this term, it will be this. So from here we get this r1 by r2, and from here we get this theta 1 minus theta 2. So now we have this z, which is equal to z1 divided by z2. It will be r1 by r2 cos theta 1 minus cos theta 1 minus theta 2 plus I sin theta 1 minus theta 2. So remember these results, very important. For the product, result is this, and for the divide, result is this. So very important results. Now let's see a very important formula, that is integer power and De Moivre's formula. So if something r complex number is given in this form, that is polar form, z equal to r cos theta plus I sin theta, and you raise to power n, means n is some integer, z to the power n, then this will equal to r raised to n, and cos n theta plus I sin n theta. So this formula, remember this formula, very important. Now let's verify with some example this formula. If mod z equal to 1, that is equal to r. So if we put r equal to 1 here, then Zn will be cos theta, means here Zn will be power of this n, and this r is 1. So cos theta plus I sin theta n will be equal to this cos n theta plus I sin n theta. So this is our formula. Now we can verify this formula. Let's put n equal to 2. Then we will get take the square of this, means a plus b square. Then you will take a square plus b square will give you minus sin square theta plus 2ab will give you this. And the right hand side you will get cos 2 theta plus I sin 2 theta. Now you can compare cos 2 theta equal to cos square theta minus sin square theta, which is, we know this is true. And from here you can compare sin 2 theta equal to 2 sin theta cos theta. So this is also true. So it is verified. You can also verify using n equal to 3. So after placing 3 here, a plus b cube, expand that formula, you will get a cube plus b cube plus 3a square b plus 3ab square. So you will get this. And the right hand side you will get cos 3 theta plus I sin 3 theta. Now comparing the real and the imaginary part, you will get these formulas. Cos 3 theta will be 4 cos cube theta minus 3 cos theta, and this is true, we know. And sin 3 theta equal to 3 sin theta minus 4 sin cube theta after comparing. So that's how you can verify this formula is true, very much true. Now let's see one kind of question can be framed from here. We know the binomial expansion, you should know about it. If there is this kind of form, a plus b to the power n, then can be expanded like nc0. We know what is this nc0, n factorial divided by n minus 0 factorial 0 factorial. It's like ncr. So it can be expanded as n factorial divided by n minus r factorial r factorial. So expansion of this is nc0 a to the power n b0, then again nc1 a to the power n minus 1 b plus nc2 a n minus 2 b2 plus, and that's how it will go on up to a to the power 0 and b to the power n. Now let's use this formula here. Cos theta plus I sin theta raised to the power n will be equal to, if we expand it binomially, it will be nc0 cos n theta I sin theta 0 plus nc1 cos n minus 1 theta I sin theta 1, and we are just expanding these terms. Okay, now we know this is equal to this cos n theta plus I sin theta. Now we will separate from this series the complex, means imaginary terms, and the real terms. So this will be real, this will be real, this will be real, and these will be imaginary. The odd terms will be imaginary, and these terms will be our real terms. So we will separate them and compare with this. Means we can take the sum of all the real terms and put it equal to cos n theta, and take the sum of all the imaginary terms and put it equal to sin n theta. So let's separate these terms from here. So cos n theta will be this, nc0 cos n theta minus nc2 cos n minus 2 theta sin square theta plus nc4 cos n minus 4 theta sin 4 theta, and so on. Likewise, you can see sin n theta will be nc1 cos n minus 1 theta sin theta minus nc3 cos n minus 3 theta sin cube theta plus, and so on. So now if in any question it is asked to you that find the nth series or the sum of nth series for the cos n theta, so you can directly, means if you need to find cos n theta, you can take the sum, and if you find need to find the sin n theta, you can take the sum. Okay, means any number you can find. So remember these two series, very important from the exam point of view. So let's take some examples based on this de Moivre's theorem. So just like we have this, so this 3 can go to the upside, so it will give you cos theta plus I sin theta 12, and here it will give you cos theta minus I sin theta 20, and here also, means you can take minus 4 here, and it will be cos minus 4 theta plus sin minus 4 theta. So it will be in the form which we use, so it will go minus 4 will go outside, so you will get minus 20 here, 12 here, and 4 will go again here, it will go, you will get 12 here, and here you will get minus 20, here is also minus 20, so they will cancel out, you will get 1. Now there is this question, very interesting question. Find value of this infinite series Rn sin theta for r equal to 0.5 and theta equal to pi by 3. We need to find this sum. So now we can use some things. How? We know already that if z is this r cos theta plus I sin theta, then Zn is equal to Rn cosine theta plus I sin theta. Okay, so if we take the sum of infinite series, then there is sum of these terms, real terms, and there is sum of these imaginary terms. So if we multiply Rn cosine theta, so sum of this will give us real term, and Rn sin and theta, sum of all these terms will give us imaginary number. So here we ask this, so we need to actually find the sum of all the imaginary terms from this Zn, because if you see, imaginary of Zn is nothing but Rn sin and theta. So if we can solve for Zn and find the imaginary term for that, then that will be equal to Rn sin theta. So let's see what is sum of Zn, means it's a Z now. Take the sum of Z. So for 0 it will be 1, for 1 it will be Z, then Z square. So series will be like this, 1 plus Z square Z cube. Now if you find the Z from here and put the value 0.5 and theta pi by 3, you will get mod of Z less than 1 and greater than 0. So if this kind of condition is satisfied, means mod Z is greater than 0 and less than 1, then this forms a GP, Z over 1, Z square over Z. We are getting common ratio Z. So sum of GP will be a Rn minus 1 divided by R minus 1, where R is common ratio. So Rn will give you 0, because to the infinity, if it is in between 0 and 1, it will give you 0. So a is 1 already, so you will get minus 1 over Z minus 1. So now minus will go downside and you will get 1 upon 1 minus Z as your sum of Zn. So I hope you get this term, how we get this. It is a sum of infinite GP, where mod of means where the common ratio is greater than 0 and less than 1. For the infinite series you will get this. Now just substitute for Z. Z is this, put the value of R is 1 by 2 and theta is pi by 3, sin pi by 3. So solve it, you will get this. Now after rationalizing this, 3 plus root 3 iota, 3 plus root 3 iota, you will get this. So sum of this old whole terms for Zn will give us this. So this 1 will be equal to this Rn cosine theta, and this 1 upon root 3 will be equal to Rn sin and theta for whole the terms to the infinity. So that was asked, that sum of Rn sin theta to the infinity. So we'll get that is equal to 1 upon root 3. So this will be your answer. So if in question it was asked that find Rn cos theta, Rn cosine theta, sum of infinite terms, then you will write it as 1 from here directly. So hope it is clear to you. Then watch it again if it is not clear to you still, and if you are still having any doubt, put in the comment section. Then let's end today's lecture here. Thank you everyone.